Hey guys, so today we're gonna solve the linked list problem. Basically, this problem are asking us to group all the odd nodes together, followed by the even nodes. Well, what does it mean? Let me explain more detail. So let's say this is the given problem, right? Remember, the first node is always considered as odd, and the second node is always considered as even. And another thing is that we need to solve them in O(n) time and O(1) space. Well, let me explain more detail. Let's say this is the given input, right? 1, 2, 3, 4, 5. So the odd is 1, 3, 5. Meanwhile, the even will be 2 and 4. So the expected output will be 1, 3, 5 to 4, right? Meanwhile, for this, remember, the first node is always considered as odd. Meanwhile, the second node is always considered as even, right? So the odd will be 2, 3, and 6. Meanwhile, the even will be 1 and 5. So that's why the expected output will be 2, 3, 6, 1, 5. Usually, to solve the linked list problem, we can use recursion or iteration. However, for this, I'm gonna focus on iteration with in-place sorting. Well, how does it work? Let me show you. This is the function name of even list. Then we are upsetting the head of the linked list, right? If the head is null or the head.next is empty, we just simply return the head itself. And remember, the first node is always considered as odd, right? So let odd is the head. Then the second node is always considered as even, right? So let even is head.next. We also need the even head y to connect with the odd nodes after we order the list. So we're gonna look through the nodes while the even is not null and the even.next is not null. Let me explain a bit. We use even and even.next and not odd and odd.next because even are list and first. We also want to make sure the even.next is not null. So on here, the odd.next will be, so this is the odd, right? We want to go to the node, from node 1, we want to go to the node 3. If this is the head, right? So it's gonna be odd.next, right? In order to be able to move from node 1 to node 3. So the odd.next is, we just simply move the pointer actually. Then the odd will be odd.next. The even is also same. Let me type it. This is even.next. Then the even will be even.next. The even is on node 2. Then we want to move to node 4, right? If only even.next, it will on the node 3, right? Meanwhile, what we want is the node 4. So we need to even.next, like on here. This is to order the even knot. Order the odd knots. And this one is to move to the next odd knots. Meanwhile for this, move to the next even knots. After we order the knots, we want to connect the odd knots with even knots. So that's why the odd dot next is the even hit on here. I'm just gonna delete this because I need some space to do the time and space complexity analysis later. Then this one is to connect the odd with even knots after sorting. Then we just return the hit. Okay, then let's do the dry run, right? Let's say the case 1, the input is 1, 2, 3, 4, 5, right? Let's add one more number, 6. Okay? Okay, so the expected output will be 1, 3, 5, and 2, 4, 6. Okay. Then during the init, the odd will be not 1, the even will be not 2. The even hit is also not 2, right? Because that is the even. Okay. So on the first iteration, the odd dot next will be at 1, right? Then we reach to the not 3, which is we already declared on here. So it will be not 3. So the odd now is 1, 3. Then the odd is odd dot next, which is not 3. The even dot next is not 2, right? And we are calling that even dot next, which is from not 2. It will on the not 4. Not 4. So the even now is 2 and 4. Even is even dot next, which is not 4. Then second iteration, odd dot next is at not 3, and not 3 will move to not 5, right? So this will be not 5. And the current odd is at not 5. Then how is the odd looks like right now? The odd will be 1, 3, 5. Then the even dot next is at not 6. How is the even look like right now? The even will be 2, 4, 6, like this. Then even dot next is not 6. Okay. Then we're gonna exit the looping, right? Okay, why? The even right now, even now is at not 6, and even.next is null, so we're gonna exit the looping. Then we connect the odd nodes with even hit, which is odd.next is even hit, and here that is not true, right? And remember, the odd, we already ordered them, right? Like this. And the hit, the even is like this. We just simply gonna return the hit, okay? Which is, it will now looks like this. 1, 3, 5, 2, 4, 6, right? And I think like this all for the diagram. Then let's do the time and space complexity analysis. This one, because we are loop through the given node, right? It will be all in time because we looping through given nodes once. All in time, okay then. Because on here we are doing the in place sorting, so it will be all one space because we don't need extra space, right? So this will be all in time and all one space. Is that correct? Let's test them, right? If one of them is null, return the hit. Then remember, the first node is always odd, and the second node is always the even, right? So let odd is the hit, even is hit.next. Then we need the even hit, which is even. Then why don't I just copy them? Okay, I will just copy them from here. Odd, this one is even, okay, let's do the test. Okay, submit. Yay! I think like that's all from me. See you next time.